All right, we made it to Friday. Woohoo! All right, today we're going to be, again, kind of finishing up our unit. We have one more thing to do on Monday, and then we're ready for our unit test next week on Tuesday or Wednesday. We'll talk about that a little bit more on Monday, how that's going to be set up. But again, test coming up right before Thanksgiving over exponential growth, decay, and then logarithms. So again, just the last couple things. So today we're going to talk about condensing logs. And that's basically, we're going to reverse the process that we did the last couple of days, where we were expanding logs. So now we're going to go backwards. All right, so basically a two-step process. First step, we're going to move the coefficients back to being exponents. That was the last thing we learned about yesterday. So again, that coefficient 5 in front of the log x gets replaced back where it was as the exponent. And then our second step is to take the adding problems and switch them back to multiply. You can see that's the green one here. Log base 2 of x plus log base 2 of y. And by the way, the log base numbers must match. Those have to match or we can't put them together. And then again, adding is the opposite of multiplying in this case. And you don't know if you remember that rule or not from last week or earlier this week. So again, I rewrite them as 1 log base 2. And then instead of x plus y, it's x times y. And then the same thing with the subtraction one and this blue one down here. Again, the base numbers have to be the same. So log base 2 of x minus log base 2 of y. And again, that reverses back to being a division problem. And you have to be careful. The one that comes first is the numerator. The one that comes second is the denominator. And it always goes that way. It has to go that way. You can't flip it. It's not the same. All right, so let's just try some with actual numbers in them, see how it works. All right, so first example. All right, so first step I need to make is I need to get these coefficients back as exponents. So this 3 is going to move back up as an exponent on the x. And this 5 is going to move back up as an exponent on the y. So that was the first step, get those exponents moved back. Next, we have to decide if this is going to be a multiply or a divide problem. And because it's an add in the middle here, that lets me know it's going to be a multiply problem. So I'm going to condense, which means write the log 2 one time instead of twice. And then the x to the third and y to the third, I'm going to go ahead and multiply those together, shrinking the logarithm down to have less parts. Let's try a few more. All right, we got 7 log base 10 of 5 minus 2 times log base 10 of 9. And again, the base 10s we don't write because they're common logs. All right, so the first step is to get these exponents moved back up to where they belong. So that means log of 5 to the 7th power minus log of 9 to the 2nd power. And since they're numbers, you technically could go ahead and multiply these out. So for example, 5 to the 7th power is some huge number. It is 78,125. And then 9 squared, you better know that one. 9 squared is 81. All right, now because they're both base 10 logs, I can re-put these together as 1 using, again, these condensing ideas. So if I go from subtraction, that's going to switch me back to division. And I want the first number, the 78,125 as the numerator, and the second one, the 81, as the denominator. And then, of course, we'd always want to make sure that that fraction can't reduce. 78,125 divided by 81. Does that reduce? And the answer is no, it doesn't reduce. But if you're not happy with that, and it makes you uncomfortable having such a terrible fraction, you could go ahead and revert that back to the decimal, 964.5 approximately. So they can get a little ugly, but again, the rules are the same, the process is the same. So again, let's try a few more. All right, next one. Again, first thing I'm going to do is get these coefficients back up as exponents. So that becomes log of x to the 5th power. And then the other one over here didn't have a coefficient, so there's no need to do any changes. All right, now it's a plus. They both have the same base, so I can put them together, kind of like combining like terms. And the pluses end up turning into multiplies. So that means x to the 5th times 8. But that should look weird to you because we never write in that order. We always put our constant terms first, then our variable terms after. So there's our final answer. All right, one more. One more. And this one's the big one. See who really gets it. All right, so first off, again, let's get these coefficients back up into the problem as exponents, but the last one doesn't have a coefficient. So that means log base 3 of x squared plus log base, oh, not 3, but 5. Goodness, I can't read my own writing. Then log base 5 of y to the 4th power. Again, that coefficient 4 moved up. And then minus log base 5 of 2. All right, now there's 3 parts, but that's okay. Let's put them together from left to right. So these first two over here on the left, let's put those together. They both have log base 5, and it's an adding problem, which means I should really be timesing those two things together. Now, kind of working left to right, now I'm to the subtraction. They both have the same base, log base 5, so I can put them together. And when you subtract, the first one, the x squared y squared, becomes the numerator, and the second one, 2, becomes my denominator. Well, a little bit harder, but you know, stuff we've been working on all week, so hopefully it seems familiar. All right, let me know if you need any help. Good luck.